All right, today we are going on an incredible journey. We're going to dive deep right to the very center of the atom. We're going to see how our entire picture of what reality is made of has changed from a simple, solid little ball to this fuzzy, strange cloud of probability. It is a story of scientific discovery that, I promise you, will change the way you see the world.
So let's start with the big one, the question humans have been asking forever. What is everything really made of? Is it fire, water, air, and earth? Or is it something much, much smaller? Our journey into the heart of matter really gets going in the early 19th century with a simple idea that finally set us on the right path.
So, where does our story truly begin? Well, for that, we have to go back to the early 1800s and a guy named John Dalton. He took this ancient Greek idea of atomos, this idea of an uncuttable, indivisible particle, and he gave it a proper scientific foundation for the very first time. And what Dalton came up with was, well, it was beautifully simple. He pictured atoms as these tiny, solid, unbreakable spheres. A carbon atom was a carbon atom, an oxygen atom was an oxygen atom, and they just click together in simple, fixed ratios to make everything we see. It was a really neat and tidy way to look at the universe. And for a long time, almost 100 years, that was it. That was the picture, the solid little sphere. But you know how science works. It never stands still. Something was about to come along and just blow that whole idea wide open. Okay, let's jump forward in time to the late 1800s. You've got these scientists in their labs playing around with these newfangled vacuum tubes and electricity, and they start noticing this weird, mysterious glow. A physicist named J.J. Thomson became obsessed with figuring out what it was. So Thomson figures out that these so-called cathode rays aren't just light, they're streams of actual particles. And get this, he could bend the stream with a magnet. That meant they had a charge. When he did the math, he realized these things were thousands of times smaller than even the tiniest atom. That solid, indivisible atom, it was a myth. Wow. He just discovered the electron.
Okay, so this changes everything, right? If the atom has these little negative bits in it, but the whole thing is neutral, there has to be some positive stuff in there to balance it out. And that's where Thomson came up with his famous plum pudding model. Just picture it, a big, squishy ball of positive charge with all these little negative electrons stuck inside, kind of like raisins in a cookie, or, well, plums in a pudding.
I mean, think about the jump we just made. We went from Dalton's simple little billiard ball to this complex sphere with bits and pieces inside. It was a huge leap forward, for sure. But our journey? Oh, it was far from over. So, next up on our tour is Ernest Rutherford. And fun fact, he was actually one of Thomson's students. He sets out to do an experiment to prove that his old mentor's plum pudding model was correct. The irony is, what he found did the exact opposite. It didn't just challenge the model, it completely shattered it. The setup was pretty ingenious, actually. His team basically built this tiny little particle gun that fired these positive particles, they called them alpha particles, at this incredibly thin sheet of gold foil. Now, if the plum pudding model was right, those alpha particles should have just blasted right through. Like shooting a BB gun through a cloud of fog, Maybe a slight nudge here and there, but that's it. But that's not what happened. Not at all. In fact, what they saw was so shocking, Rutherford himself said it was as incredible as if you fired a 15-inch cannonball at a piece of tissue paper and it came back and hit you. Just impossible. Something was completely wrong with the whole plum pudding idea. So here's what they actually saw. Yeah, most of the particles zipped straight through, just like they expected. But some got knocked way off course at huge angles. And then a tiny, tiny fraction, we're talking like 1 in 8,000, actually bounced almost straight back. Bounced off a pudding? No way. This led Rutherford to a conclusion that is just mind-blowing. The atom is almost entirely empty space. All that positive charge and pretty much all the mass, it's all packed into this unbelievably tiny, dense point right in the center, which he called the nucleus. To put that in perspective, if the nucleus was the size of a marble in the middle of a football stadium, the electrons would be flying around way out in the stands. The solid world you see around you, it's basically an illusion. It's mostly nothing. Okay, so Rutherford's model was a game changer, absolutely. But it had one tiny, fatal flaw, a huge one actually. According to all the physics they knew at the time, His atoms shouldn't be able to exist for more than a split second. So what was the problem? Simple. Opposites attract, right? So why wouldn't the negative electrons just get pulled into that positive nucleus? Classical physics predicted they should lose energy and spiral inward, causing the whole atom to just collapse. But obviously that doesn't happen. The universe is still here. So what gives? This is where Niels Bohr steps in. And his solution was, well, it was revolutionary. He basically said, what if the old rules of physics just don't apply down here at the atomic level? He came up with this planetary model, where electrons are stuck in these specific fixed orbits, kind of like planets circling the sun. So Bohr laid down some new rules for the atom. Rule 1, electrons can only exist in these special allowed orbits, these energy levels. Rule 2, as long as they're in one of those orbits, they don't lose energy, so they don't spiral in. They're stable. And Rule 3, they can jump between orbits, but only by absorbing or spinning out a perfect little packet of energy, a quantum. This was brilliant. It explained why atoms were stable, and it explained why different elements glow with specific colors of light. Bohr's model was amazing, it really was, but it wasn't the end of the story. Our journey is about to take its final, biggest leap, right out of the world of predictable orbits and into the truly bizarre, mind-bending world of quantum mechanics. And trust me, this is where things get really, really weird. So get this, the modern quantum model just throws the whole idea of an electron as a little planet right out the window. It turns out an electron acts more like a wave. We literally cannot know its exact position and its exact speed at the same time. The best we can do is define a 3D zone, called an orbital, and say the electron is probably somewhere in here. So the atom isn't a tiny solar system after all. It's more like a fuzzy cloud of pure probability. But this fuzzy quantum world isn't total chaos. Oh no, it has very strict rules. Electrons have to fill up the lowest energy levels first. And each little orbital can only hold 2 electrons, tops, and they have to be spinning in opposite directions. It's this super specific, rule-based arrangement that gives every single element its unique personality, its chemical properties, and basically dictates how everything in the universe interacts. Wow, okay, let's just take a breath and look back at how far we've come. We started with Dalton's solid little billiard ball. Then Thomson cracked it open and found electrons, giving us the plum pudding. Rutherford came along and blasted that pudding apart, showing us it's mostly empty space with a tiny nucleus. Bohr tried to tidy it up by putting electrons on fixed tracks. And then, finally, quantum mechanics came in and smeared those tracks into weird clouds of probability. What a ride. So we've gone from something solid and simple to this bizarre dance of probabilities that underpins all of reality. And every single step of the way revealed a world that was deeper and stranger than anyone could have imagined. It really makes you wonder, doesn't it? What's the next discovery going to be? What else is hiding down there, waiting to completely change our picture of the universe all over again?